Okay, so something is wrong with the universe. Or maybe it's better to say something is wrong with our understanding of the universe. For the first time in a long, long time, the cosmic rulebook we thought we'd almost figured out, well, it's starting to show some serious cracks. But here's the wild part. That's not bad news. In fact, it might be the most exciting thing to happen in physics for a generation. Let's get into it. I love this quote because it just perfectly nails the feeling in the science community right now. It's not doom and gloom, it's this thrilling sense of anticipation. See, for decades, cosmology was getting a little too neat, a little too tidy. Now we might be on the brink of a revolution, a shift in thinking as big as when we realized the Earth wasn't the center of everything. The universe is finally getting weird again.
You know, for most of our lives, physics has been in this period of calm. We've had what's called the standard model of cosmology, which is basically the master blueprint for the universe. It explains the Big Bang, what everything's made of, the whole shebang. And it worked. It worked so well that it really felt like we were getting close to the end of the story.
But then, we built better eyes. Our telescopes got unbelievably sharp, our data got more and more precise, and as the picture got clearer, we started to see things that, well, they just didn't fit. Little glitches in the matrix. At first, it was easy to dismiss them as noise, right? Just tiny errors that would go away with more data. But they didn't. The cracks just kept getting bigger.
So, historically, when a great scientific theory starts to break, it tends to go one of two ways. Sometimes you get what we call a Uranus moment. See, the orbit of Uranus was weird. It didn't follow the rules. And the solution was that we were just missing some stuff, a whole other planet, Neptune, whose gravity was messing with it. But other times you get a Mercury moment. Its orbit was also weird, but no amount of missing stuff could explain it. The problem was deeper. We needed a whole new idea about how gravity itself worked. And that new idea was Einstein's general relativity.
And that is exactly the cosmic crossroad we're standing at right now. Are all these new cracks we're seeing a Uranus moment? Do we just need to find some new, invisible stuff out there in the cosmos? Or are we in a Mercury moment? Are we on the verge of needing a completely new, revolutionary way to think about reality itself?
So, to figure out which path we're on, we have to play detective. We have to look at the evidence. And right now, the evidence is piling up around 3 huge, major cracks in our theory of the universe.
So let's go through these cosmic clues one by one. And I'm just giving you a heads up. This is where the story starts to get really, really wild. Clue number 1, cosmic monsters. Our telescopes are spotting structures in the universe that are just impossibly huge. I'm talking about a string of galaxies 10 billion light years across. For perspective, that's nearly a tenth of the entire observable universe. According to our standard model, gravity just hasn't had enough time since the Big Bang to pull together something that massive. It simply shouldn't exist. So why is that such a big deal? Because it seems to break the most fundamental rule in the book, the cosmological principle. This is the bedrock idea that if you zoom out far enough, the universe is basically the same in all directions. It's uniform. It means that what we see from our tiny little spot is a fair sample of the whole thing. But these giant structures, they suggest it might not be.
And this analogy just puts it perfectly. If the universe isn't uniform, if our neighborhood is special somehow, then everything we think we know could be based on a totally biased view. We might literally be like an ant on the single cherry of a giant, complex cake, thinking the whole cake must taste like cherries.
Okay, on to clue number 2, and this one is a real head-scratcher. The universe appears to be expanding at 2 different speeds at the same time. Yeah, I know how that sounds. When we look deep into the past, at the early universe, and we calculate its expansion rate, we get one number. But when we measure how fast the universe around us is expanding today, we get a different, faster number. It's like your car's speedometer says you're going 67, but your GPS says, nope, you're doing 73. They can't both be. Now, for years, scientists just assumed this had to be a measurement error, but as our tools got better and better, the problem only got worse. The chance that this is just some random accident, a statistical fluke, it's now less than 1 in a million. So no, this isn't a fluke. Something is fundamentally broken here, either in our measurements or, more likely, in our theory.
And that brings us to the third big clue, this one coming from the incredible James Webb Space Telescope. Our theories are pretty clear. After the Big Bang, it should have taken about 500 million years for the first big, mature galaxies to form. But Webb is looking back into that cosmic dawn and finding them way, way earlier, as early as 280 million years in. They're popping up almost twice as fast as they should be.
And this is the best way to think about it.
It is literally like walking into a kindergarten and finding a bunch of fully grown adults. Not only are these galaxies there way too early, but they also look surprisingly mature, full of complex elements that should have taken way longer to create. It's completely baffling, and it tells us we're missing something huge about how the universe got started.
So, let's recap. We have cosmic monsters that are too big to exist, we have a universe expanding at two different speeds, and we have impossibly old galaxies in a baby universe. You see, these aren't just separate, isolated puzzles. They're part of a growing pattern that's pushing cosmology from a period of calm into a genuine crisis.
And honestly, it doesn't even stop there. Other smaller, nagging problems are piling up too. There's way less lithium in the universe than our Big Bang models predict. Dark matter, the invisible glue holding galaxies together, isn't clumping up quite right. And even dark energy, that mysterious force pushing everything apart, might be changing over time. All the main pillars of our theory are starting to look a little shaky.
So when you put all of this together, the big picture is just impossible to ignore. For the first time in a generation, cosmologists are having to admit they're not sure what the universe is really up to. There's this growing sense of confusion, of crisis. And believe it or not, that is the best news we could have hoped for.
Because here is the most important thing to take away from all this. In science, a crisis doesn't mean failure. It's not a bad thing. It's a sign that the whole process is working exactly as it should. It means we're on the verge of learning something new, something deep, and something profound.
This is how science has always worked. It doesn't move in a straight line. It moves in cycles. You have a long period of calm where a theory works really well. But then a crisis begins as all these little anomalies pile up. That leads to a period of confusion and wild new ideas, which eventually leads to a revolution, a brand new theory that reveals a deeper truth. And then a new calm begins. We're living right in the middle of step 2.
So just remember, these cracks aren't a sign that our science has failed. They're a message. The universe is practically yelling at us, telling us that our current story is incomplete, that there's more to discover. The cosmos isn't broken, our theory is just too small. And that means things are about to get a whole lot more interesting.
Which brings us right back to that ultimate question. Are we about to find a cosmic Neptune, some new, missing piece that snaps the old picture back into focus? Or are we about to be blindsided by a cosmic Mercury, a revolutionary idea that forces us to rewrite the rules of the universe as we know them? We don't have the answer yet, but finding out, that's going to be the adventure of a lifetime.